Okay, there are 20 questions in this paper. The first question is based on halogenation of alkenes. So in this, butane is reacted with chlorine. So the products are 1-chlorobutane, 2-chlorobutane. So yield is 27.3 and 72.7%. So we can write if the reactivity of the 1-degree hydrogen is X, 2-degree hydrogen is Y. So 27.3% yield we can write it as. So there are 6 primary hydrogens, 6x plus 4 secondary hydrogens. Sorry, 6x by total reactivity is 6x plus 4y into 100. Similarly, we can write the percentage yield of 2-chlorobutane is 72.7 is equal to 4y divided by 6x plus 4y into 100. Okay. Here what is asked? Secondary hydrogen reactivity, that is y. Y divided by x we should calculate. This is 1, this is 2. Divide 2 by 1. So we'll get 2. Next question is question number 22. This question is based on the Daltons Law of partial pressures. There are 2 gases, X and Y. Partial pressure of X is 1. Total pressure is 1.5. So partial pressure of Y will be 0.5. So Px by Pb we can write it as 0.5. This is equal to what? Weight by molar mass. So 2 by mx, 3 by my. So it is asked to calculate my by mx. So my by mx. From this we will get 2. Okay. Next question number is question number 23. In this Mg2C3 is allowed to react with the water. It is hydrolyzed. So on hydrolysis, what does it produce? Mg2C3. Mg2C3 on hydrolysis produces 2 moles of magnesium hydroxide plus C3H4, which is propane. So propane is formed in this reaction. Okay. So magnesium hydroxide plus C3H4. So 1 mole Mg2CO3 is giving 1 mole of C3H4. So answer is 1. Next question is question number 24. In this question, this CaCrO4.H2XH2 is heated. It is losing 18.7% of mass. So that is due to the loss of water molecules. So percentage loss is 18.7. That is equal to x moles of water is x into 18 divided by molar mass is 192 into 100. So from this, x will become what? X equal to 18.7 into 192 divided by 18 into 100. Okay. So this on calculation will get it as 2. Okay. Next question is question number 25. This is based on equivalent weight of As to S3. As to S3 on oxidation, it is forming ASO4 3 minus plus SO4 2 minus. In this case, it is oxidized from +3 to +5, -2 to +6. The number of electrons is 2 into 2. Here sulfide is -2 to +6, 8 into 3. Total is 28. So equivalent weight is molar mass by 28. That is equal to m into 14 into p. That is given in the question. So p will be 2 from this equation. Okay. So next question. Question number 26. We should identify the molecules with non-zero dipole moment. U should not be equal to 0. Here there are different molecules. CH2Cl2 doesn't have the dipole moment 0. It is having non-zero dipole moment. Methane, due to the symmetrical structure, its dipole moment is 0. CCl4 also having the dipole moment 0. Water, due to the bent shape, it is non-zero molecule. CHCl3, due to the asymmetrical structure, its dipole moment is non-zero. Para-dichlorobenzene. So due to the cancellation of the dipole moment, it is a non-polar molecule. Ardocresol will cancel the dipole moments of each other. Okay. So OH and CH3 are polar groups. So sorry, this two doesn't cancel their dipole moment, so it is polar. Paraxylene is CH3. These two cancel their dipole moment, so dipole moment is 0. SCl2, so this is 0. SCl2 is again due to lone pair, it is bent molecule, so it is polar. Okay. So BF3 is due to the cancellation of net dipole moments. So net dipole moment of these two fluorines will act in this direction. So it is a non-polar molecule due to dipole moment 0. IBr is linear molecule. Due to electronegative difference, it is polar. So here we have these molecules. SCl2 is polar. BF3 is non-polar. IBr is polar. Formaldehyde is also polar. Due to polar CH and CO bonds. So in this case, the polar molecules will be 1, 2, 3, 4, 5, 6, and 7. So 7 polar molecules are there. So 7 is the answer. Next question. In this question, it is based on the extraction of the metals, which is involving the self-reduction method. Self-reduction method is used for the copper, lead, and HGS. After roasting, the partial roasting is done, and on heating continued, this undergoes self-reduction. The metals copper, lead, and mercury will be extracted by self-reduction method. So answer is 3. Okay. So next question is question number 28. In this question, there are 2 alkenes are hydrogenated to give the products. Here X number of products are formed. Here Y number of products are formed. The number of products excluding stereoisomers we should determine. Okay, first we write the alkenes possible in reaction 1. In reaction 1, it is C double bond C, F, Cl, Br, I. Structures I am writing. C double bond C, F, Br, Cl, I. C double bond C, F, I, Br, Cl. This on hydrogenation will give CCl, FCl, CCFCl, Br, this product. This on hydrogenation will give this. This on hydrogenation will give CCF, Br, Cl, This on hydrogenation gives C, F, Br, Cl. So these are the products. They can exhibit the stereoisomers, but only structures we need to count. So 3 products are formed. In second one, the alkenes possible are 1-butene, 2-butene, and isobutene. So these alkenes on hydrogenation will give butane. This gives butane. This will give isobutane. So the different products are, these 2 are same. So 2 products are formed. So total products are 3 plus 2, that is equal to 5. Okay. So question number 28, the answer will be 5. Next, question number 29. Here there is optically active 2-chlorobutane. So 2-chlorobutane is chlorinated. It is asked what are the possible products. So 2-chlorobutane on chlorination will give, so 1,2-dichloro, that is B option. 2,2-dichloro, that is option A. 2,3-dichloro, that is option C. And 1,3-dichloro, that is option D. So all A, B, C, D chloro derivatives are formed in this reaction. So A, B, C, D is correct answer. Next, here some reactions. Question number 30. There are some compounds are given. It is asked which pair of compounds will give the same gas on reaction with dilute HCl. Here the reactions are, first reaction, calcium is reacted with HCl. So calcium is a metal, react with the HCl, which is active metal, liberates hydrogen gas, gives CaCl2. And calcium hydride, ionic hydride, H minus of hydride react with H plus to give H2, and it will give CaCl2 also. So the products, same products possible in these two cases is calcium and calcium hydride will give H2. So B is K2CO3 and K8CO3. K2CO3 and K8CO3 reacted with HCl. Both on acidification will give CO2 gas plus KCl plus water. Here this also will give the CO2 gas plus KCl plus water. So both will release the CO2 gas. Similarly, both are carbonates in C option, calcium carbonate and K2CO3, both are carbonates. Both will give the CO2 gas on acidification. So in D option, the compounds are calcium nitride. This on acidification will give the N3 minus takes up H plus ion to give the ammonia plus calcium chloride. But calcium phosphide on acidification will give the CaCl2 plus phosphine gas. Okay. So all this will give the same product, ABC. Here hydrogen, here CO2, here also CO2, but here different products. One is ammonia, other is PH3. So the same products are obtained in A, B, and C. Next, question number 31. In question number 31, there is a alkyl chloride which is reacted with sodium diether, which is Wood's reaction. So in Wood's reaction, we can assume the radical formation CH3 HD. Okay. So the different products possible on combination of these radicals is, two radicals will combine to give this product A. Okay. Here the radical flipping is possible during the combination, so B is also possible. C is not possible because there are two deuteriums on same carbon. Here it should be, deuterium should be on the adjacent carbon, so it is not possible. So this is also possible because B and C are enantiomers. So B and D are enantiomers, which can also be formed in this reaction due to the flipping of these radicals. So A, B, D are formed. Here it is asked which is not obtained in this reaction. So the compound C is not obtained. So C is the correct answer for this question. Okay. Next, question number 32. This question is asked about the ores. It is asked correct statements. Okay. So calamine and cerussite are the carbonates ores. Calamine is ZnCO3, cerussite is PbCO3. So both are carbonate ores. A is correct. Rutile and cuprite. Rutile is TiO2, cuprite is Cu2O. Both are oxide ores. So this is also correct. Zinc blend is ZnS. Iron pyrite is FeS2. So both are sulfide ores. This is also correct. Malachite and azurite are given as the sulfate ores here. So this is incorrect because these are not sulfate ores. These are carbonates. So the difference here is malachite is CuCO3 dot CuOH twice. Azurite is 2CuCO3 dot CuOH twice. Here these two are the carbonate and basic carbonates. These are not sulfates. Hence correct will be only A, B, and C. So for 32 question, A, B, C is correct answer. Next, question number 33. in this question, there is an equation given. This is PV, P into V minus B is equal to nRT. Here, we should plot a graph between D by P versus P, where D is the density of the gas. Okay. So here P into P into V minus NB is equal to nRT. On expanding this, we'll get PV minus PNB is equal to nRT. So dividing this with nRT, we'll get PV by nRT by minus PB by RT is equal to 1. So from this, we can write PV by nRT is equal to 1 plus PB by RT. Here, in this case, here we need to draw the density. Density, we can write it as D equal to PM by RT. Here we can write this as PV. This is weight, number of moles is weight by molar weight into RT is equal to 1 plus PB by RT. Now this becomes density, that is V by W is equal to 1 by D. So 1 by D. So 1 by D into PM divided by RT is equal to 1 plus PB by RT. Okay. Here we need D by P. So taking the reciprocal, this becomes DRT by PM is equal to 1 plus PB by RT inverse. Okay. Here in this case, we are plotting D by P. So if you write D by P, that becomes M by RT into 1 plus PB by RT inverse. On expanding, neglecting the higher terms, we'll get 1 minus PB by RT. So this is equal to M by RT minus P into MB by RT whole square. Okay. So this is Y, this is intercept C, this is X, this is slope M. Okay. So slope is minus MB by RT square, that is B option. Intercept is M by RT. Okay, that is A option. So intercept we are getting M by RT. Okay, so let us do the next question. Next question is the question number 34. Question number 34 is based on the properties of the compounds and elements. Here there are some compounds: ClO2, SO2, CO2, P2O5. ClO2 is more acidic than CO2. This is correct. But here CO2 and P2O5 acidic character is not correct, because P2O5 is more acidic than CO2. Okay. Next. So this is not correct. Correct statements is asked. Second one is second ionization enthalpies. Second ionization enthalpies of Na plus. Okay. What are given? The Mg plus, Al plus, and Si plus. Okay. If you write the order, here it is 2s2, 2p6. This is 2s2, 2p6, 3s1. This is 2s2, 2p6, 3s2. This is 2s2, 2p6, 3s2, 3p1. Okay. So silicon is 2s2, 2p6, 3s2, 3p1. Silicon plus 1. Okay. Here sodium will have the highest ionization enthalpy. This is correct. Sodium is highest. But between silicon and aluminum, okay, so Si plus and Al plus has higher ionization enthalpy because it is removed from the 3s subshell. 3s subshell is more penetration than 3p. So energy required from 3s will be more. So aluminum should be more than silicon. Here silicon is given as the more than the aluminum. So this is also incorrect. Okay. Third one is based on the electron affinities. Electron affinity down the group decreases, but in 16th group, oxygen has the least electron affinity due to its small size. So this is correct option because sulfur, selenium, tellurium, least is oxygen. Next one, the acidic nature of H3PO2, H3PO3, and H3PO4. So this is P double bond O, its conjugate base is O minus H and H. This is P double bond O, O minus OH, H. H3PO4 conjugate base is P double bond O minus OH and OH. So this, if this anion is more stable, this is more acidic. But in the case of second and third, due to cross conjugation of OH groups, this stability of O minus is decreasing. Hence, more the cross conjugation, less is the stability of the anion. Hence, less is the acidic nature. So, D is also correct. So, for this question, the correct answer should be C and D. Next question, question number 35. Here, amphoteric oxides and hydroxides are asked. So, zinc hydroxide is amphoteric, so correct. Beryllium oxide is amphoteric. Al2O3 is also amphoteric. PbOH5 is also amphoteric. So, answer will be A, B, C, D. Next one is, it is the halides, their solubility is asked. So, here we should identify the true statements. So, LiF, lithium fluoride, is less soluble in water. So, it's sparingly soluble or insoluble in water due to its high lattice energy. Lattice energy is Q1, Q2 by Rc plus Ra. Due to small size of Rc and Ra, its lattice energy is less. If lattice energy is more, what happens? Its lattice energy is high due to small Rc and Ra. If lattice energy is high, to break this LiF into Li plus and F minus, it requires very high energy. Hence, it is insoluble in water. So, it is less soluble in water. So, high solubility of BeF2. BeF2 is water soluble. It is readily soluble in water because Be plus 2 due to the small sign and high charge. So, due to high charge, this will take the more water molecules and its hydration energy is more. So, the sum of hydration energy of Be plus 2 and F minus dominates the lattice enthalpy. So, it's high soluble in water. So, CSI is less soluble in water. This is also correct because CS plus and I minus are larger in size. Due to large size, their hydration energy is less. As hydration energy is less, what happens? So, their lattice enthalpy cannot be compensated by hydration energy values. Hence, this is very less soluble in water. So, if you take Ki and KCl, so Ki is more covalent because here cation is same, potassium. Then covalent character depends on the polarization of anion. As I minus is larger in size, it is more covalent. As it is more covalent, it is more soluble in organic solvents like acetone. Hence, this is also correct. So, for this question, A, B, C, D is correct answer. Okay. So, next question, question number 37. Here, there are some alkenes are given. It is asked which of these will give 2 moles of formaldehyde, 1 mole of butanone, and 1 mole of the cyclic component, 1 mole of glyoxal. So, if you write these products on ozonolysis, this will give this CH2 is there. Here also there is CH2. It will give this 2 moles of formaldehyde plus, if you break here, this will get CHO and CHO. So, 2 moles, 1 mole of glyoxal is formed. That is CHO and CHO. If we break this, this will get converted to butanone plus. So, this 6-member ring with C double bond O, CH3 and C double bond O formed. So, which are the required products? So, A is correct. So, if you do the ozonolysis of second compound, so these two are converted. This one and this one are converted to formaldehyde. So, 2 moles of CH2O formaldehyde plus if you break this, we'll get the 6-membered ring, double bond here. So double C double bond of CH3 here, C double bond O plus, if you break this, this will get converted to glyoxal, that is CHO, CHO plus this unit get converted to the 2-butanone. So these are the again required products, 2 moles of formaldehyde, butane, glyoxal and the cyclic compound. So B is also correct. Now if we take the option C, this on ozonolysis will give, this will get converted to butanone. So this will get converted to formaldehyde, CH2O. This one get also converted to CH2O. So if we break this bond, this becomes glyoxal, CHO, CHO plus this will become the 6-membered ring, double bond here, and C double bond of CH3. So this is again the required products are formed in this reaction. So ABC is correct here. If you check the D option on ozonolysis, this will give formaldehyde and formaldehyde, 2 moles of formaldehyde plus, so if we break this, we'll get the 6-membered ring, double bond here, so double bond here and CHO plus 2-butanone. So this is the not required product here, and glyoxal is not formed. So this doesn't give the required products. So required products are formed in the reactions A, B, and C. Okay. So next question. Here, this is based on the titrations here. Some compound is given KHC2O4, H2C2O4.2H2O. Its normality as acid is given. So that is KHC2O4.H2C2O4.2H2O. Here it can lose this H plus and this 2H plus. So its N factor is 3. So we know that normality is equal to molarity into N factor. So molarity is, it is asked. Molarity becomes how much normality by N factor, that is 3. 0.25 by 3. This becomes 0.083. Okay. So whether it is an acid or reducing agent, its molarity remains same. So B and D are correct. So now it is asked the normality as the reducing agent. When it is a reducing agent, KHC2O4 plus H2C2O4 will get oxidized. So this oxidized to CO2, this is also oxidized to CO2, 4 moles of CO2. Here it is changing from +3 to +4. So N factor is 1 into number of carbon 4. So 4. Hence, the normality becomes molarity into N factor, that is 0.083 into 4. This is equal to 0.332 N. So A is also correct. So for this 38th question, ABD is answer. Next, question number 39. The question number 39, chlorobenzene is given. It is subjected to different reactions. The nature of the products and properties of the product is asked. So chlorobenzene Cl is orthopara directing. So the products obtained in the reactions are, so we'll get Cl SO3H plus Cl SO3H. Okay. So now this is major product here. Okay. So ortho is major product. So it is incorrect for P. Dipole moment of the major product is non-zero. So these two are the different groups. This is correct. Para product is major product. So this is correct. Now in the major product, IUPAC name of the chlorine number. So here 1, 2, 3, 4. It is not 1 chloro. It is 4 chloro. So this is incorrect. So A matches to Q and R. Okay. Next, nitration of chlorobenzene. Chlorobenzene on nitration will give the Cl NO2 ortho. So Cl NO2 para. So para product is major product again here. So this major product, again here ortho product is major, that is not correct. This is not correct for B option. Dipole moment is non-zero. Chlorine and NO2 groups are different. So dipole moment is non-zero. This is correct. Para product is major. Here the IUPAC name Cl and NO2 both are not principal functional group. We go according to alphabetical order. So this is 1, 2, 3, and 4. So 1 chloro, 4 nitrobenzene. So this is also correct. So for the B option, so we'll get here Q, R, and S. So B option will get Q, R, and S. So in third option, chlorobenzene is chlorinated. So we'll get the orthochloro, orthodichloro, and paradichlorobenzene. Okay. Here ortho product is major. This is not correct because it is again para major. So for C option, this is not correct. Ortho product is not major product. Dipole moment of the major product is non-zero. It is incorrect. So major product CCl bond will cancel the dipole moment of each other. So dipole moment is 0 here net. So this is also incorrect for this. Para product is major. Here its name is 1,4-dichlorobenzene. So carbon attached to chlorine is 1. So this is also correct. So here the correct answer would be for C, R and S. For D option is chlorobenzene is acylated. We'll get Cl COCH3 plus Cl COCH3. Again, this is major product. Okay. So here, if we write the ketone group is the principal functional group, the numbering starts again from here. 1, 2, 3, 4. Now, if you check the options for the D, so ortho product is major. This is incorrect. Dipole moment of the major product is non-zero. This is correct because different groups are there. Para product is major product, correct. It is not 1 chloro. It is 4 chloro. So this is incorrect. So for this, we'll get for D option again Q and R. Okay. Next.